Hello fellow problem solvers. So today we're going to be doing a cool number theory problem that I suggest you try out for a minimum of 20 minutes, ideally 45, but not more than an hour and a half. If on the other hand you'd like to go along with us, I suggest you take 10 to 15 minutes and put your first ideas out on paper. So now, let's begin. So, what the problem is asking is, does there exist an infinite strictly increasing sequence such that this sequence, a1 plus k, a2 plus k, n plus k, all the way till all the members of the sequence, still infinity, contains only a finite number of primes, and it does so for any such integer k. Now, the first sort of intuition is, what is this like? How would you, if you wanted to construct such a sequence, how would you do it? And now, you need to use the fact that your numbers are going to be increasing. So, no matter what the k, you can have your numbers become very large and hit very large gaps of consecutive composite numbers. And with this question, there are really two ideas that people try. One is to have n factorial, have a n be equal to n factorial. And now at some point, you will have that k will be less than some n, k is bounded, it's a fixed integer. And then starting from that point, you'll have n factorial plus k, k will divide this, and then this will not be a prime. And that's all fine and dandy, but it runs into one problem. And that is, what if k is equal to plus or minus 1? You don't know whether this sequence, n factorial plus and minus 1, contains a finite number of primes or an infinite number of primes. And now there are two ways to fix this problem, and I invite you to pause for the next 5 to 15 minutes and try to fix the problem. Try to see if you can construct a sequence, if such exists. And one of the answers is, well, you only have a problem if you have plus and minus 1. Can you factor it? So one idea is, well, instead of making it a n being n factorial, I'll have it be n factorial to the power of some odd number. Constant, even just n factorial cubed. And now every single one of these numbers will still be divisible by k for k not equal to plus or minus 1. And if k is 0, then this will just be divisible by n, it will never be prime. And for this example here, if k is plus or minus 1, well, then you can factor this as n factorial plus minus 1 times n factorial squared minus plus n factorial plus 1. And then you have two numbers, this stops being equal to 1 very soon, and you're done. Now that's one way of dealing with the problem, and I think this is a very cool trick, so I wanted to show it to you. But another way is, well, what you're really doing here with just n factorial plus k is there's these gaps, and you're making the number get into one of these gaps of numbers which are all prime, all composite. The gaps are from really n factorial plus 2 all the way till n factorial plus n, and they go in the other direction, n factorial minus 2 all the way till n factorial minus n. That's sort of what you have. Now, the only thing you really need is to make sure that, wait, these gaps get arbitrarily large. You're just starting out from n factorial and you're adding k. Why don't you start out from the middle? The gaps will get very large, and that's what you do. So you just make a n equal to 2n factorial plus n. And now, at some point, what will the sequence be? It will a n plus k will be 2n factorial plus n plus k. At some point, no matter what this is, what k is, it will be less than 2n, and it will be greater definitely than 2. If you take n large enough, k is fixed, you'll get this, and then you'll get only a finite number of primes. Now this solves our problem. I think these are two very interesting approaches. I've done similar problems with composite numbers, a bunch of consecutive composites, and I like the fact that I'm showing to you that this idea comes up again and again in different problems. It's just about your creativity to find out how you're going to use it and make it fit the problem at hand. This solves our problem, and as always, thanks for problem solving.